In this example, we want to let v be the vector with an initial point of 2, 5 and a terminal point of 8, 13. And also want to let w be the vector with component form -2, 4. We then want to find the following: the magnitude of v, the sum v plus w, the scalar multiple 3 times v, and the difference v minus 2w. We start by finding the magnitude of vector v. In order to do this, it's helpful to have v written in component form. Given the initial and terminal points that we have for v, the component form of v will have components 8 minus 2 and 13 minus 5. And so our component form for v looks like it should be 6, 8. So v is the vector with components 6 and 8. Once we have the component form for v, we can find its magnitude by taking the square root of the sums of the squares of the components. So this will be the square root of 6 squared plus 8 squared. 6 squared is 36, and 8 squared is 64. So we have the square root of 36 plus 64, which is the square root of 100, better known as 10. So the magnitude of vector v is exactly 10. Next, we want to find the sum v plus w. Based on what we've just done, we now have the component form for both v and w. We know v is the vector 6, 8, and the component form for w we were given as -2, 4. And when we add two vectors in component form, we simply need to add the corresponding components. So our first component will be 6 plus -2, and our second component will be 8 plus 4. And so v plus w is given as the vector 4, 12. Next, we want to find the vector 3v. In order to do this, we want to take the component form for vector v, which we found earlier to be 6, 8, and multiply each component by 3. So 3v will be the vector with components 3 times 6 and 3 times 8. And so our component form here will be 18, 24. Here we're just multiplying each of the components of our vector v by the scalar 3. And last but not least, we want to find the difference v minus 2w. Again, we're going to use the component forms for these vectors that we know. V is the vector 6, 8, and we're going to subtract from that 2 times vector w, which we know is -2, 4. We're first going to handle the scalar multiplication in the second vector. So we're going to multiply that vector by -2. So that means we're going to add to it -2 times -2, which is 4, and -2 times 4, which is -8. And so we have our first vector v, which is 6, 8. We're going to add to that -2w, which would be 4, -8. And when we add the various components here, the first component is 6 plus 4, which will be 10. And the second is 8 plus -8, which will give us 0. So v minus 2w will be the vector 10, 0. Next, we want to let a be the vector with component form 7, 1, and b the vector with an initial point of 3, 2, and terminal point -1, -1. We want to find the magnitude of vector a, express b in component form, and find the difference 3a minus 4b. You can pause the video and try this example yourself, then resume the video to see the solution in a few seconds. Since we're given vector a in component form, The magnitude of A is simply the square root of the sum of the squares of the two components. In this case, that would be the square root of 7 squared plus 1 squared, which is the square root of 49 plus 1, or the square root of 50. So the magnitude of A is square root of 50. To express B in component form, we simply subtract the x coordinates and the y coordinates from the terminal point and initial point. And so our component form will have the first component of negative 1 minus 3, which is negative 4, and a second component of negative 1 minus 2, which is negative 3. So the component form for vector B will be negative 4, negative 3. Then to find 3a minus 4b, we're going to use the component forms for both a and b. So we have 3 times the vector 7, 1, minus 4 times the vector negative 4, negative 3, which you'll recall is what we just found in the previous part to be the component form for vector b. We then multiply each component by the appropriate scalar. So 3 times 7, 1 becomes 3 times 7, which is 21. And 3 times 1, which is 3. So 3a will be the vector 21, 3. We then scale vector b by negative 4, and so that becomes positive 16 and positive 12. And notice that we're now adding our vectors since we used negative 4 as our scalar. And so we have 21 plus 16 is 37, and 3 plus 12 is 15. And so 3a minus 4b will be the vector 37, 15.